Okay, so we are beginning. So welcome everyone to another one of the Siemens technical webinars. Today we're going to get the opportunity to take a look at the turn mill side of the world. We're going to kind of explore what do we mean by the turn mill term, what can you do, what capabilities are native within the control in this type of technology set. So I am going to be your moderator for today, Chris Pollock. So I manage the Technical Application Center as well as our business development team for international business. So I am certainly a resource here for you guys. My contact information is there in front of you. Um, I tend to specialize more in topics from an operation and programming perspective, but I can also just help people navigate through the world of Siemens. So certainly, I'm sure a lot of you are kind of aware on how large an organization Siemens can be. So if you have any questions, you need any help, certainly I'm here as a resource. Now, before we get into the main topic, I did want to point out a couple key websites that if you're not familiar with, you're going to want to check out. So our primary landing page is our CNC for You website. There's a lot of stuff you can find there. Certainly our webinars are there. It's kind of designed to be all things centric to end users from an operation and a programming perspective. So it's really tilted for really the use of our control, and as well as promoting our webinars and having links to our past webinars, we do also have different training material you can get to. We offer two different types of training. We have virtual or in person. And within the virtual realm, we have an interesting Excel spreadsheet, shall I say, which we call our SINUMERIK Content Manager, which allows you to actually get access with direct links to all of our online material. So what I would suggest is if you get a chance, go to CNC for You, pick the training link, go over to virtual training, you'll see the link for a content manager, and that gives you this little spreadsheet here. And what that does is it has really all of our events, and you can use that top selector across the top bar of that spreadsheet to kind of pick and choose what your maybe skill level is or your technology interest, and then the document will automatically highlight videos you should start taking a look at. So additionally, we do offer training, and the training can be both online or virtual, or online or in person. And those training classes can all be found on CNC for You. When it comes to both the virtual or the in-person, we have a whole series of instructor level led classes. So it had been a little while, obviously, with the state of COVID and everything was going on, that we had suspended our in-person classes, but they are up in full swing. We're offering some advanced classes. Next month, we're doing our 5-axis class. We've rescheduled all of our service and maintenance style classes. So if you haven't checked it out, I would say go over, take a look. All of the training we have available is 100% complimentary. Now, additionally to CNC for You, don't forget about the Mr. CNC YouTube channel. So on Mr. CNC, you're going to find certainly that's where we post all the webinars. That's where the links to the webinars are. But there's a lot of other video material we put out there. We do little how-to videos, little promotional videos. We also promote other colleagues' videos. So not stuff that's just produced here in the US, but what our colleagues in Germany and other regions are doing. So you can find all kinds of information on the Mr. CNC YouTube channel. So if you don't know it, head on over there. Make sure you follow it and like it. Certainly, the more engagement you guys give us, the more we get continued funding, and we can keep on doing more and more of this stuff, which we all like to do. And we also have a program that my colleague Daniel Vitullo manages, which we call the VPE, or the Virtual Product Expert Program. And what that allows you to do is you can actually schedule a one-on-one product demonstration with a product expert. So whether it be Dan or myself or one of the other guys in the team, we can go in and actually work one-on-one with you. It's online, but it's certainly fully live. So if that's something you're interested in, you can get to the VP program as well from CNC for You, and you can then schedule a time slot. So with that being said, Dan Vitullo is actually here online with us. So let me say hello to Dan and welcome you as as part of all of our followers here. I'd be the first to welcome you to the channel again. You have certainly had a chance to do some past events with us. So welcome, Dan.
Thank you, sir. Thank you.
All right, so Dan is going to be our presenter on the MILL-TURN topic. Dan's been with us now for, I think, going on 8 or 9 years now, right?
Actually, I got to fix that. It's 8 years.
It's 8 years. All right,
Yeah.
perfect. So Dan and I have been working together for a lot more than 8 years, probably 20,
Plus
25
20.
plus.
Yeah.
Yeah, a long, long time. So certainly good to have you here. So again, welcome. We're going to switch over. So give me 1 second to give Dan the full rights. All right. All right, Dan, you should have full presenter rights.
You got me?
We gotcha.
Okay. Excellent. Well, thank you for the introduction, Chris. I appreciate it. Thank you, everyone, for joining us today. We're going to be covering topics related to MILL-TURN and specifically in shop mill. So we're going to start off with just a brief introduction on what we mean by MILL-TURN and how our technology works. And then I'm actually going to be introducing you to a new product for us called MyVirtual Machine. This will be related to the control SINUMERIK ONE. Then after looks like I have two MyVirtual Machines in I didn't notice that. Tool setup, technology cycles, and then we will get into programming apart with turning technologies and so first things first, the control that this applies to is 840D. These topics do not apply to the 808 or the 828, but also the brand new control, the SINUMERIK ONE. So the SINUMERIK ONE is going to be the control that will eventually be replacing the 840. This is our brand new control coming. It's been out for a year and a half, Chris, 2 years, something like that. I'm a little fuzzy on the details on when we released it, but
Yeah, it's been like 2 years now.
Two
Absolutely.
years, give or take. Yeah. So it's definitely the future of Siemens from a CNC standpoint. It's a very exciting product, seeing where Siemens is taking controls, and I think everyone, once they get in front of it and really see what this control can do, it's going to really show a lot of people what's possible. So we need to make the designation or differentiation between a turn mill and a MILL-TURN. Siemens definitely separates these two in the sense of the way that our technology works, because is that machine's technology primarily a lathe? Like if you took the milling portion away, would you still have a lathe? If you took the turning portion away, would you still have a mill type thing? So right now we are dealing with our webinar is on the topic of MILL-TURN, which means the primary technology of this machine is mill. And then the turning was added to the machine. We have done a webinar on turn mill. Chris did that a few months ago. Actually, it was longer than that. And it's a very good webinar. I highly suggest taking a look at that if you are interested in, say, a B-axis head on. So what kind of makes this special in the sense of how these machines work? So you take a mill or you take a lathe and you add that other technology to it. How does this all work together? So what we basically do is we take all of the technology cycles that you're accustomed to using, and then those become available in your opposing technology machine. In this example, we have a mill, a 5-axis mill, and the one we're using today happens to be A carry C kinematic, so a table-table kinematic. And we're adding the turning capabilities to that and adding all of the cycle support that you're used to. So if you've ever run a Siemens turning machine, that same cycle support is in there that you're used to with the contouring. And where do our challenges lie when we start looking at doing these operations? So what are some of the concerns if you're looking at purchasing a machine that has mixed technology, or you're looking at adding this to your shop? What are the things that you need to look for in a control? So one of the big things is, how does it handle the planes? So when I'm in milling, I'm generally in G17. If I'm turning, I'm in G18. So how's it handling those plane shifts? How's it handling the tool alignment? Because now I've got to position my tool at multiple angles. This is a 5-axis machine. How is it handling those tool alignments? Tool direction. How is it handling which way my tool is pointing? What direction is the spindle turning? And what happens to my program when I change that spindle direction? Radius and diametric positioning. So how am I positioning? Is it based off of the diameter of my part, radius? All of these things I need to really pay attention to when I'm looking at these types of machines. Otherwise, I'm going to have to do everything in the post-process before it even gets to the machine. Can the machine manage these things? Actually, can the control? So where Siemens comes into play here is we actually have both technologies combined in one machine. And when Siemens designed these technologies, they didn't design them separately. They designed both platforms at the same time using the same control. So the integration of milling and turning into one control really was seamless, because it was always kind of meant to be that way. It was a mill and it was a lathe at the same time. Why not just put these together? And we do this without needing to do any kind of technology shifts. So there's no M code or G code to put it into a turning node, per se. The cycle handles it. And this is specifically talking with shop. This machine is shop mill because it's a mill, but it has the turning, conversational turning. So from a kinematic standpoint, what type of machines generally are we going to see this on? So you have two basic types of machines. You have a mixed kinematic machine, where you have a head that rotates and then a table. And then you can also have, and I'll show you in the next slide, a table kinematic. So what's important here to note is, how does that tool attitude get adjusted and manipulated by the control? You need to have at least a rotary table and some form of angular position. So this is the head, and this can be nutated. This can be a B axis. It can be a axis up at the top. It doesn't have to be a specific axis, as long as this axis will rotate to position. Then you have your table, and this is more what probably most of us are used to seeing, whether it be a B carries C, or in this case, an A carries C. We generally see this. And this is what handles all of the cool angular position. So next, I want to talk a little bit. I'm not going to go into a full-blown webinar on Run My Virtual Machine. We do have plans to do a full webinar introducing Run My Virtual Machine, but since I believe this is the first webinar that we've used it in, I wanted to talk about it a little bit. So this is the tool that all of us are familiar, if you're familiar with our webinars, with seeing SINUTRAIN. So this is kind of like the SINUTRAIN for the SINUMERIK ONE, but what it does is a little different. It gives us the ability to have a full machine model running with the system. So this is a digital twin of a specific machine. And these, the model that it uses, a 3D model, is created from step files. So you create the assembly, and then that can be then built into the Run My Virtual Machine simulator, and you get a full simulation of not just machine, but also the PLC is possible. And when you're running it, it runs as though you're running the machine. So it really is a true digital twin, beyond just the simulation of the machine, it's simulating the control simultaneously. And you can even get into more elaborate machine models. So this is one of our builders that has committed to using MyVirtual Machine. This is their model that they've used, and these are all the STLs for their assembly for the machine. If you were to take all the skins off the machine, it would be just like this. And one of the really nice features of this is it goes beyond, and this is run MyVirtual Machine right now, it goes beyond just simulation, because I can actually simulate not just my my machine tool, but I can also simulate any of my work holding. So I have all my work holding in here that is available for this machine, so I can change to different work holding, whether it be a vise or clamping or anything, and I can zoom in on that, around, and as I jog this machine around and move it, it will then it'll show me where things are starting to interfere. So if I was to just rapid my Z straight down into this part, see it'll turn orange and then it turns red. And it allows me to actually move through those. So it's not going to stop the system. This is collision detection. So I can run through a program and then actually go and look and find all of my collisions and what collided with what. So it was the tool colliding against the clamp, things of that nature. Very, very powerful tool for simulation and for testing out your programs. And this is just the tip of the iceberg. Chris will definitely be doing a webinar at a later date on this, and we'll get a better idea and see more of what it contributes. So when we think about doing a mill turn, obviously there's going to be some new stuff that wasn't traditionally in that cycle. Maybe it's that turning cycle or a tool cycle or things like that. So what kind of has changed and what's been added to this layout that's going to allow me to do these things? And what do they do for me? So one of the first things is in TSM. So 2 new fields in TSM or 3 new fields, I'm sorry, is the beta, the angle, and the gamma. So this is not B, this is beta. And what this is the kinematic independent orientation and angle of your tool. So when I set this to a beta 45 and the Y 0 or a gamma 0, then I get what you see here on the screen, which is my A axis rotating to 45 degrees, and then my tool angle is at 0, which you probably can't see it, but the tool tip is facing. The other thing that you get added is you get now in your header, you're going to have retractions for turning, which you probably didn't have before. Well, if you didn't have a mill turn, you didn't have it. So all of your normal, if you're used to programming in shop turn, from a shop turn header standpoint, your normal retraction, and also your spindle limit for CSS. Those are both also available in your header page. From a turning standpoint, when you start going into turning cycles, some of the technology turning cycles, again, you're going to have your beta and gamma field for orienting the tool. This is highly important because if you're going to be turning anything, you need to be able to position that tool tip so that that tool can address the part correctly. Now, what you're accustomed to seeing in a standard milling machine is no turning tool. So you just have all your normal end mills, drills, and everything, which you still have in this. But now you've got to add all of your different tooling and your orientations for those tools. So when you bring up a mill turn, and let's go ahead and go back to our mill turn, and when you take a look at our tool page, you can see if I go to create a new tool, I now have all my turning features. And the control is keeping track of which orientation your tool is in. Now, generally speaking, you're going to be either using the OD tool or the ID tool, the ID orientation or one of the neutral orientations. That's generally what you're going to be using for a mill turn, because obviously I'm not going to be having my tool pointing up towards my spindle. But this first column here in Siemens is always the natural orientation of the tool. Another feature that you may see in these is going to be the multi-tool. So what a multi-tool does is it allows me to actually create a tool that has multiple sides to it. So say I say this is a four-sided multi-tool and I give it an input angle, I can define each one of these cutting edges of that tool at a different angle. So, 0, 90, 180, 270. So then what will happen is when I select that specific tool, it will actually rotate the multi-tool around every time I call up that different multi-tool. So we'll have the multi-tool 1, multi-tool 2, multi-tool 3. So what happens with this tool when we do start rotating? So if you're familiar with Cycle 800 on a 3+2 machine or a 5-axis milling center, then these cycles that are these parts of the cycles or specific cycles will start to kind of, they make sense to you when you start thinking about it because you're used to doing the kinematic independent rotations. You can do direct axis on the tool orientation, but then you're managing that, not the system. And I really suggest, especially in conversational programming, really you want to use the kinematic independent or the beta and the gamma rotations for your orientations of the tool. So what happens is when we set this, the whole coordinate system shifts. So we're actually changing the tool, not the part. And that's where you have to get your head around when you're doing these rotations. Don't think about the part turning. Think about I'm rotating the tool to the part. And then everything starts to make sense because anytime I turn that tool, I'm switching the coordinate system. And you'll see as we move forward how that works. So the first thing is when you're in like a head table kinematic, you're going to have your beta and your gamma on the spindle. So this beta is the rotation or the rotational angle of the tool, and the gamma is the rotational angle of the tool around the spindle. So that means that I can actually physically rotate this tool to plus or minus 5 degrees or 180. So 180 and 0 plus or minus 5 degrees. And then once these rotations are done, then the coordinate system takes over. Same thing with the head, with the table machine. My beta is going to be around the A, and then my gamma is going to be around the spin. What this does for me is that means that I can use one tool to do multiple operations. So every one of these positions that this tool is getting to are all with the same tool. I'm not changing tools here. All I'm doing is changing the beta and the gamma of the tool to achieve that new location or rotation. And the entire time this is going, this spindle is running clockwise. And you can see the tool's flipped for a cutting edge for a clockwise spindle rotation. If I was using conversational programming and I switched that spindle direction, it would actually turn the tool over the opposite. And I will show you that. One of the big advantages of using a tool like this or a mill-turn in a situation like this is we can actually rotate the angle of the tool and get relief on the backside of a cutter that I normally wouldn't be able to get without changing inserts, angles, or holder angles, or the total holder itself, whatever it be. I can do a lot more work with the same tool. So in this, I'm able to use the same tool for OD as I am getting into an undercut, and treat it more like a neutral tool. And when you do these rotations, and you'll see that in the demo coming up, the system is managing that tooltip rotation, handles it all for you. So you don't even have to think about it. You just say, okay, I need to cock this over, and then my program is going to. Another unique little secondary thing here is we can actually rotate, as I said before, the gamma of the tool. So that's the tool's rotation in the spindle, not around the spindle. So what that means is I can rotate it by plus or minus 5 degrees. The system limits it so you don't wind up breaking the tool or the insert. But what that means is if maybe I need a little more rotation to get a better engagement of my cutter or maybe on my tool, I'm sorry, or maybe I'm trying to get a little more chip break out of it, I can rotate that cutter engagement to get maybe a better relief at the bottom of the cut. Whatever it is, to fine tune that cut using the gamma. So how does this all work? Rotate this B, the system will rotate. And then if you watch, as soon as that turn tool carrier turns on, I then get a diameter here telling me that my x-axis is positioned in diameter. When that tool carrier is off, my diameter goes away. So let's take a look. Machine, and let me get myself back here to the correct. Blank. Is this up? Z up and out of that part. So right now, I have no tool carrier active and there is no rotation around my X. So if I just come in here to TSM and I tell it beta axis 45, cycle start. Oh, Y0, my bad. Didn't get the gamma. So now it's rotated and you can see it oriented the tool as well. But the real nice thing is you can see it put me into the diameter mode. So I have diameter mode on now. Whereas prior to that, the diameter mode was not on. And my turning tool carrier, very important, is on. So this is very similar to Cycle 800. This is a tool carrier for that tool. So the system will manage this. So if I start moving around, it's actually going to move on that new vector. Oh, my Z's at the limit, so my Z can't go down, go anymore. That's why. So this, okay, switch back. So now moving along, let's talk about technology cycles. So technology cycles are what we use for programming and conversational. So all of those cycles, you may have never heard the term technology cycles from us, but that's what they are. So the integration of these all will be very familiar to anyone who's ever used our control. So all of your turning cycles are available, your milling cycles are available, including your measuring cycles. Now, one of the added bonuses of a mill turn is you now get your part probing in jaw, whereas in a turn mill, you do not have options in jaw. You still have them in auto, just not in jaw. All these cycles are standard in shop mill and shop turn. So when you activate shop mill, shop turn on your control, you'll get all of the technology cycles. You may, if you want that, there's options that obviously associated with there. What do the technology cycles look like? So the only thing that you're going to notice is you're going to have, in program guide, they won't look any different, but in conversational, you're going to have your beta and your gamma skew. In program guide, your cycles will be driven outside of the conversational for your angle. So you follow a specific cycle for setting your tool angles. Then all of your geometry calculator things for doing, creating contours. In fact, we have a contour in the program we're going to be running today. Those are all supported as well. And any of your threading routines, all supported, just like they are standard machine shop. And they work the same. That's the beauty of it. It seems the cycle. The only difference between in shop-turn is going to be obviously the beta and the new aligning here. So just kind of a reiteration of it all of your contour editor, stock removal, contour grooving, plunge turning, all still available, all ready for you to use. In fact, we're going to be using them. So that all being said, let's get down to the nuts and bolts of things and start looking at creating a part program. So we are going to be doing this basic shape here with the groove and some milling on top. It's just a widget. So the first thing we need to do is bring up our program header and make sure we set up some retracts and our spindle limit for our spindle limit for CSS. So to save some time, I already have a program written, and I'm just going to be moving items from it as we go and then simulating as we go. So let's call this one webinar. I come into my header here, and this all should look any different than what any of you are accustomed to if you're accustomed to SINUMERIK. If you're not, the way the header works is the first thing it's always going to ask for is my work offset, and then how I want to draw my part. And there's multiple selections here, how to draw a part. Then I tell it the diameter, and if you notice on the left, it's always trying to help me understand what's going to happen by putting a number in to this field. This is the top of my part. So I'm leaving a millimeter for finish paths. My block is 100 millimeters tall. I'm in G17. I'm retracting to 100 millimeters above the part. I'm doing a simple retraction. So there's multiple types of retraction, and this is where, if you're used to milling, this is new for turning. And so I can either do a ID and OD retraction or a back turn retraction as well, or no retraction. So we're going to do a simple retraction, just OD. We don't have any ID work here, with a 5 millimeter incremental retraction from the Z and the X. And then I'm limiting my main spindle to 1200 RPM when I'm in consistency. And this safety clearance is the place where it's going to wrap the two to begin feeding on the part. And if any of you have ever had to try and teach someone new to machining the difference between climb mill and conventional mill, this graphic really helps. And you can see here, that's obviously climb milling. And if I change this, it will be conventional mill. So we want to climb mill. And then this is how it's going to wrap it in between operations, whether it's going to be optimized or go to the full retraction plan. Once I put that into the program, then I now have my header. And I can actually simulate just the header. So it'll just draw me my header. So there's my block that I'm going to be machining. So going back to the presentation. Now what we want to do is we want to do that first facing cycle. So I'm going to use a stock removal cycle, apply a angle to it, and then face off my part. So now let's go back to the machine. And this is where I'm going to use a cool little feature. Some people aren't aware of this, but in SINUMERIK, you can actually open two programs next to each other. So if you're in the edit mode of the editor and you select this arrow here on the bottom right, get this open further program. And this allows me to actually select another program to open. They'll open next to each other, and I can move or copy items from one to the other. So I can just use my copy button here over this guy and paste it in, and now I have that cycle over here. And when I open that, then I can see here what we've got. So I'm using a roughing tool that's 55 degrees. I'm going to do a retract in my Z and X and Y when it goes to do the pull the tool away. And I'm rotating my beta axis. that's the angle that I am cutting the tool with the tool to 45 degrees, and I have my gamma set to 0. Now, a couple of things here. This is also a new field where if I wanted to mill or turn this with the tool pointing forwards or with the part pointing forwards or backwards, I can change that by changing this field here. So right now, it's in a negative. So watch what happens when I go to machine. So I'm just going to go ahead and put this into execution right at the start, machining this part. So now if I just come over, tool, is in the teacher. Reset this. Let me clear some stuff out here and get myself away from this part. Start over. There we go. Wouldn't be a webinar if there wasn't some kind of something that came up. So as you can see, it managed that for me. All I had to do was give it the center of this part and the top of this part when this was in a 0-0 situation. When I probed it, it was pointing straight up, and I probed the top, and I probed the outside diameter, set the center and the top. And now the system managed that tooltip knowing where it is. There we go. Next thing we need is a, we need to turn the OD down using the contour editor. So we're gonna turn this contour down, and I want to step back for a second and show you something. Before we go right into this, I want to talk to you a little bit about what just happened with that tool. So let me backtrack back to machine, and I want to bring up a different program. So what's going on here is we're actually moving this tool around the part. So by using swivels. So this first cycle here is just setting the tool carrier to 0. It's putting everything back to 0. And then here what I've got going is I'm using the tool alignment cycle, and I'm calling up a finishing tool, and then I'm sending it to a 90-degree angle and a 0 gamma, and then positioning it to 100 millimeters in the X and 0, 0 in the X and Z. And then I'm doing that all throughout here. That's all this does. These cycles, each one of these is positioning that tool to a new angle and a new position, but always 100 millimeters diameter. It's always going to the 100 millimeter diameter. So when I execute this, I'll show you what this is. And so it's going to come up, change to a different tool. Now it's coming down, and so now that tool is right up against the edge of the part. And take note, this is the first position, so this is B90. Take very clear note of where that insert is, because we can manipulate that by using the spindle direction. So then if I come to the next location, it's going to rotate around. Now I'm at a B of 45, but all I did was send the tool back to X 100 millimeters. So you can see it's maintaining that tool location for me. And it's also, if you zoom in and you can see it, it actually is maintaining it based off of the cut direction. So right now it's wanting to do an OD. You can see how it's calculating the radius of the tool, and it's actually positioning my tool offset so that I can do an OD. Then I come over here, I'm rotating on the other side, and I'm coming back over this side. And these are all positive x-axis moves. And the way I got it to the other side was that position negative, position positive that you saw inside the cycle here. So what this is this rotates which side of the part. It's going to rotate your A, but it's still going to consider it a positive rotation. So then if we come back over here, we go back down, now we're at the 90 degree. Kind of hard to see because of the machine. Now, let's take a look. So going this direction, you can see this is a clockwise spindle direction. So that means this spindle is spinning this way, right? Now, what if I'm sorry, this way. What if I change the tool direction? So in conversational, our tool direction, our spindle, I'm sorry, not our tool direction, but our spindle direction is controlled by this field here. So if I just change this to spin the other way, now what I run that program, watch the first rotation. Remember this tool was facing the other way before? And accommodated for the offset of the center line of the tool and the cut direction of the tool. And as I go through, it's going to maintain that all throughout the program because that spindle direction was changed. So now the tool's on the other side over here. So the system is maintaining all that for me. I don't have to think about which direction I'm holding the cutter or anything. The system will maintain it as long as I have all the correct, everything correct in there. I can't tell if this tool's facing one way when it's really facing the other. Other than that, the system manages it all for me. So that being said, let's now get into doing the contour. So I want to go ahead and do the contour cut for the roughing of this part. Sorry, my PowerPoint. Okay, so back to run my virtual machine. Let's go ahead and call back up our two programs. And so this is my program that I'm building. So I'm going to go ahead and grab the first part of this, which is the contour and the stock removal for the roughing. So the first things first, let's take a look at the contour. So just if you've ever programmed any of our contours, the only thing that you may see that's different is it's vertical, obviously, because this is a vertical mill. So the orientation of the drawing is going to be vertical. But this is a drawing tool that allows me to calculate and find missing points and draw the part as a work step. So as an example here, everything in gray that's here, the control calculated for me. So when this was programmed, we didn't know the z-axis position. So the system figured it out for me. Then this x-axis line, we didn't know where it ended. Z-axis line, I'm sorry. This z-axis line, we didn't know where it ended. The system was able to figure all these out based off of the geometry that was around it. And then we go into our stock removal. So here, we're calling for a roughing tool. And in this case, I am not roughing it. And I am taking it to a 45-degree angle and machining with the gamma at 0. And then it's just roughing, and I'm leaving some finish allowance on the Z and the X. And then one of the things that's kind of critical to using these cycles is anytime there's anything that's under another entity in an OD, you have to give it an undercut. So you have to set this relief cut to yes. And then that'll go ahead and simulate what it's done so far. Comes in, machines the outside, and then it's going to go ahead and come on down and take the what of the contour it can do. So as you can see, this relief angle on this tool doesn't allow me to get the entire undercut. So if we execute this, change tools for me. Bring my tool in. And it'll begin cutting. My facing operation. And my handle B. And you'll see the same thing, but here I can actually visually see the tool and the angle that it's held at, that it's not going to be able to get into that undercut, but it will cut what it can. That's what we're going to use another cycle to finish off the rest of that. But this simulation really brings the machine into your office in a sense. Having all of the ability to do this. If I had any kind of, if I had set this angle to 90 degrees, I probably would have seen that the head was interfering with the table or something. So let's go ahead and go back to our PowerPoint. So next is going to be the residual material cut. So what residual material does is residual material is a cycle that we call into the chain of cycles that allows me to have the ability of cutting only what the previous cycle missed. So when we add this to the cycle, it's a little like this. Back into our editor. I'll go ahead and copy my residual material cycle in. And you probably see I've done a few different ways of copy and paste. Probably should be talking about those while I'm doing them. But you can right click if you have a mouse. You can also use under the edit key, your vertical keys. A quick little tip, if you think about these keys down here as your what's, these keys up here as your how's, if the control starts to make sense from an edit standpoint, a navigation standpoint, what do I want to do? I want to edit my program. Well, copy and paste with an edit feature. So they're under the edit. What do I want to do? I want to drill. Well, then when I select drilling, how do I want to drill? So, quick little note. You also can use your Control C, Control V, Control X commands from Windows. Those also work in here as well. So let's go ahead and go right to execute on this. And I'm going to start the beginning. And actually, so we'll only be running with that. Change to the correct tool. And I want you to take special note of something that's happening here in this program. So even though this is a residual cycle, you notice that that residual cycle wasn't able to get into this little area because of the angle of the tool that I chose. Now, I did this on purpose so that I could show you something. So maybe I go through my simulation and I want my residual cycle to be able to figure that area out and get it prepared for a finish pass. If I go into my program correction and I just make the smallest little change to my beta, just 70 degrees on my beta, so execute now, go to run this. Now, because of that new angle change, it actually can get into that residual. So now you can see the benefit of having that B-axis. It really opens up tooling that you wouldn't have been able to use before to be able to get into some of those critical areas like here, where I can use this one tool to do quite a bit. And then now all I have to do is come in and start talking about my finish pass. So finish pass, I'm not sure if you've noticed, but all these passes have been chained to this contour. So they're all designed to work with this contour. And again, I have my beta and my gamma field that I need to adjust to be able to have this part work. So we'll go ahead and go back now. And we'll add finish pass. So I'll go ahead and open up that program. And I'm going to grab this finish pass right here. Save it in here. And so we're going to use that same 62-degree for my beta, but now I'm changing to a 35-degree tool. And then gamma is going to still be 0. So that's my tool orientation. And I'm doing a finishing pass. So for those that aren't aware, there's multiple types of passes you can assign this one cycle. So roughing, finishing, finishing, and roughing. Now, if you choose finishing and roughing, it's doing it all with the same tool. But the reason they use single triangle and three triangles is very similar to like how a print is created. When you look at the print finished dimension, it's always 3 triangles. So that's kind of the logic behind why it's a triangle, running triangles with finishing. So again, now if I execute this, we can do it. Now in shop-turn, I'm not sure if you've noticed what's happening, but if you have your cursor in the editor on a line and you hit cycles and you hit execute, it instantly brings you into block search. So if I wanted to run this program as a whole, I would have to hit reset. If I want to run it from here, after it's been reset, I can then go block search and hit start search, and it will allow me to run the program from that. So it's going to go up, do my tool change, request another cycle start to confirm I want to keep going, and we can re-engage, and now it's going to go ahead and do my finish bits. So now here's my finish bits. So this shape is now completely finished and to use, and all I have to do now is go back to my print, and now we need to add a groove to this. So I'm going to do my grooving obviously at 90 degrees. So maybe my work holding was a little too big and it didn't quite fit in there. This would show me up, or show me that maybe if I had an interference or something. Thankfully, the tooling that we chose for this does not. So moving back to our part program. Here's my grooving cycle. Go ahead and paste that into my program and execute it from there. Again, it puts me into block search. So it wants to execute from there. It will initiate the tool change. If it knows it needs a tool change to do that mid-program start, the system is managing it. And it always is going to, don't be alarmed when you get this red message. It's just telling you, hey, you need to just press cycle start again to confirm that you really, really want this. And then comes in, and it will go ahead and cut my groove. I'll go through the grooving cycle here. So on the grooving cycle, just like the other cycles you've seen, and I know I'm beating this over the head, but having this beta and the gamma is very, and knowing about it and having it, or knowing how they work is very, very important. So in this case, I'm actually rotating the tool 180 degrees to engage the tool with the spindle direction on purpose, to a specific direction, because I want it to be moved in a specific direction. And my beta is rotated to me, obviously, because we want that bottom. This field here, I'm not sure if anyone's familiar with it, but what this field does is this allows it to use Traore to move between locations. So if you combine this with an incremental retract, means you can just retract say 10 millimeters above your part and then do your rotation. The tool will actually track with the rotation. I'm not sure if you noticed, but in the previous demo where I was showing the tool alignment to the part, I was using this feature. So now Now we want to do a little bit of threading. And again, it's just a matter of setting my correct beta and gamma to get the threading tool aligned to the part the way I need it to be. And then calling the cycle like I would in a normal turning machine. So go ahead and add that to our program. So now we want to add the threading. Control Z works great. So the way the threading cycle, if you've ever done threading on a Siemens, this should all look familiar. It's just a matter of like all the other cycles, you fill in the blanks. So we're not doing a retract. We're going to run our beta at 90 degrees and our gamma at 180. We're not using any of the built-in tables. There are built-in tables for creating threading operations. So let's say I was doing a metric. Say I was doing a metric thread. Have a whole host of tables of different metric sizes and then the associated pitches. So we're just using here. Keep on hitting the wrong key on my keyboard. And then it's a matter of giving it a pitch, giving it now when you're not using a table, you can actually vary the pitch distance. So you can incrementally change that pitch as it goes, increasing or decreasing it. Spindle RPM. Now you can also use constant surface speed and threading if you want. And it's because generally we're going to use the same tool for roughing and finishing and threading. We are doing a roughing and a finishing pass. A couple of the unique things to our threading cycles that you generally don't see. You can have your depth of cut either just be a linear distance, or it can actually be digressive. So each pass, it will take a lighter cut. So as you get that engagement, that full engagement of the threading tool into your thread, you're not generating as much tool pressure as you would be if you had a full engagement taking the full depth of cut like you would from the beginning of it. We're doing an external thread. We are at 18 millimeter OD, and we're doing 30 millimeters of thread. And my thread height is 0.92 millimeters, and it's at 20. So now we go ahead and execute this as long as I didn't mess up any numbers in there. Should come in. I hit that finger in a bunch of keys, so I may have messed up my threading cycle. But we'll find out real quick here. Yeah, I messed it up. Let me, there's the beauty of having simulation, right? Mess up a number, you can always go back and fix it. Easy fix for this is to just.
I was going to say the crash direction, the crash protection really kind of came in handy.
Came in handy.
That,
Right
that
there.
would be bad. For sure.
Yeah, that is not the, as they say, that's not the droid I was looking for. But I wasn't paying attention to, well, I was paying attention, but I fat fingered a bunch of numbers. And let's go ahead and correct this now. There you go. That looks more like it. Now I'll reset the blank and we'll redraw the entire thing from scratch. As you can see, it's able to thread, no problem. And it's doing everything at the angle. And if this tool was able to work at a different angle, I could switch the angle and do it. Obviously, this is a perpendicular tool, so I can't run my beta at any other angle.
So Dan, how did you get the work holding in the model?
The work
The
holding.
chuck and stuff.
Okay, so those are brought in through STLs. So I kind of showed it, but not really, because I didn't want to go too far into that, because I'm assuming that you're going to cover it when you when you cover the run my virtual machine. But we have a whole library here. So these are all STLs that can be brought into the control, both the blank and the actual clamping. So I have different work holding that I have loaded in here that were brought in as STLs and loaded to be part of the system. And so the system actually knows that this has volume and shape. So when any entity that's being moved around on the table, because of the way this is integrated, it knows it's there. It knows the jaw's there. It knows the chuck is there. And so it can not avoid, because this is not collision avoidance. This is collision detection. This specific machine does not have collision avoidance turned on that I'm running, but the model has collision detection. Does that make sense? Does that answer the question for them, Chris?
Oh yeah, absolutely. And you're right. We'll go into a lot more detail when we do the webinar
Yeah,
on
I
this.
figured you would. So I didn't want to, I'm at 3 o'clock and I'm not done. So I didn't want to go to too much detail on that. I was already kind of pressed for time. So I'm going to go ahead and in the background while we're doing something else, let this get to the point where we are. So now we're switching to milling. And this is kind of, notice I never did anything to tell this thing, hey, you're in turning mode. There was no M code, there was no nothing. All the conversational cycles handled that for me. Once it saw that turning tool carrier be activated by telling the tool to go to a specific beta or gamma orientation, then it said, oh, you're orienting the tool with a beta, you're in turning. And it went ahead and put the machine in turning. So now I've got to turn that off. I've got to turn my turning off by activating my swivel cycle. So I have to activate this anyway, because I'm going to be milling. And when we're in a 5-axis machine, the first thing we always do is activate our swivel plane to do my retractions and set the machine up to the correct 0. So let's go ahead and do that. So if I come back to my machine, should be almost done machining. Well, while this is machining, we'll go ahead and background edit. And I'm going to grab my swivel plane, talk about this a little bit. And notice we're background editing while the machine is running. Oh, it won't let me edit the program while it's running. Give it a minute. In fact, you know what? I'm just going to do it. I'll talk about the cycle. So the first thing is which tool carrier am I using? So we're gonna, the name of this tool carrier is tool_carrier 10. So machines can have multiple tool carriers. Generally, you're only going to see in a MILL-TURN tool carriers available to you, maybe only one, depending on the type of machine it is and what options it have on it. But then I'm going to be changing to an end mill called slot mill. Or actually, I think this is yeah, that's an end mill. And then there's no retract involved. We're going to allow the system to handle. And then, yes, I'm going to swivel. And so what this means is it's going to actually do the swivel. If I had this set to no, I would have to follow this cycle with a position command. This way, it's going to actually put the machine to 0. And this is a new swivel. I can have additive swivels, so I can have it be like an incremental swivel of the system. What this cycle does is it takes my coordinate system and it moves it. So the first fields, these fields are actually, I like to say they're setting up a hinge, the place where you're going to perform this rotation. And we're rotating the tool. Even though the part on this machine, it's a table machine, I understand the part is the thing that's physically moving, but we're really not moving the part. We always want to think that we're about this in the sense that we're moving the tool, Because then if you think about it that way, well, first off, it's the correct way to think about it. But secondly, when you go from a table to a head to a head table, you don't have to think about how's the machine moving anymore in Siemens. All we have to think about is how do I want that tool to approach that? And then the system will take care of everything. Then from there, we're going to be doing what's called a kinematically independent rotation. And again, Chris has covered this quite extensively in the 3+2 programming webinar. Highly suggest if you haven't seen it, take a look at that. Really good webinar, much better than my one. Then we have our actual rotations. And you notice these don't say A, B, C, they say X, Y, Z. So in this case, I could actually do a rotation around the Y-axis, and then the system will take care of that. It'll move my C and my A to give me whatever angle I was trying to get in the Y, because that becomes a 2-axis rotation. And then I have a last minute little datum shift. After everything's rotated, I can move my 0 around. And then when that's all done, that now becomes the new 0 of the machine. In this case, I want the machine to go back to G17. So once that's in the program, then we execute this. Now what's going to happen is the system's going to go up, change the tool, and zero out my rotaries to their 0 location. So now I have a new tool. You can see I put in my tool. I'm ready to begin machining the top of this part. So if you remember back from the print, we have a square on the top of that part. Should have this thing. So what we're going to do now is we're going to do this there's a pocket in the top of this part. And we're just going to call up a standard pocketing cycle. And this doesn't have any rotations because I'm doing the rotation using the cycle 800. So it's just a matter of actually just going back into my program, calling up my rectangular pocket, and pasting that in. Now if we execute this, we'll see that it's going to start again. We're starting, everything else to this point has been turning. All I did was my cycle 800. You can see my turn went away, and then it's still displaying the diameter, but it's actually not in that. No, it's not. It's not displaying. It's got a dot. So, cheating. Save time. We get right back to drilling. While that's running. So our drilling cycles. I'll do all the drilling cycles all at one time. So center drilling. A little unique thing about our center drilling cycle, this is like if you're used to like a G81 or a cycle 81, we can actually define the depth of your drill by the diameter at the surface of the part. So I'm telling it to do a 4 millimeter diameter chamfer on this part. And then in our drilling cycles, I'm using the deep hole drilling cycle, and this is a chip break, but it can also be a chip removal. So if I have this set to chip removal, it will fully remove the drill bit from the part each pass, clearing all my chips. And then I'm drilling to the shank as opposed to tip. So this is my drilling, how I'm describing the drilling depth. This is another slightly unique thing. I haven't seen this too much, but in other controls. But what you can do is you can set your depth based off of the shank of the drill. This is really handy when you're breaking through things, or if you're going to be tapping, and you want to make sure that the tip of your tap clears, the tip of your drill bit clears, so that anything with the tap doesn't get into the taper of that. And then I'm using a position pattern search. So this is just the way that it selects where to drill those holes. So it's a 16 millimeter radius, and it's 4 holes. And You can actually set this up to go from hole to hole as a circle. So if there was a boss sticking up in the middle of this, I could actually have a very low retract and avoid that boss moving around. So if we go ahead, and I'm just going to grab all of this. Paste that in. Now when we run this, we'll go ahead and the block search wants to know which hole I want to start from. So I want to start from my centering and then hole 1. So I could actually have started from the drill bit and hole 3. Will allow me to do a block search from anywhere. It's a very intelligent block search. We've gone through the block search quite a bit in other webinars. I believe in the tips and tricks webinar, we looked at block search quite extensively. So block search, definitely a good one to look at. I know Chris has covered it in some of the other shop mill webinars and the team program guide webinars. So definitely something we've covered quite a bit. And now we have a finished, well, almost a finished part. But as you can see, I mean, we've even shown some of the collision avoidance. I made a fat finger mistake on my part program and wound up crashing the machine. Well, we were able to discover that, find it, get through it, and move on. It's part of the beauty of this Run My Virtual Machine tool. Really, really a just indispensable tool now in the modern way we program, especially when you start getting into these advanced technology machines where you're mixing technologies and things can get confusing quick if you're starting to do a lot of entries and, like me, talking at the same time and trying to create programs. So that being said, got questions, Chris?
All right. Well, great job, Dan. Thanks for going into that very informative webinar on MILL-TURN. And we do have some questions in the queue. Plus, I would encourage those of us on the call, if you have some questions, type them into either the Q&A panel or the chat panel, whichever you happen to have up. And while we get some additional questions, let's start going through some of the ones that first came in. So one question that came in, can I add turning to my existing 5-axis machine?
The limiting factor there is going to be the rotational speed of your C-axis and also how that C-axis is defined. That really is a question for your machine tool builder. Generally, what I have seen, I hate to say it, is no. Because, you know, if they don't have it set up to do that, there's quite a bit of commissioning involved in the background to make turning work. I mean, Chris, you may say something different than me there, but it's not something I'd see most builders do.
So, I mean, I would agree with you. I think your hardware limitation would be the RPM of your primary turning axis, the rotary axis. In this case, it would be usually the C axis. If you think of a
Sometimes,
traditional rotary axis, you're limited to 22, maybe 33 RPM. Certainly not enough to do any real effective turning. Yeah, you're right. There is a lot of other commissioning, but the commissioning itself from the machine control side isn't really that bad. It's really a hardware limitation. So I would say if for some reason your machine has a high-speed rotary, it could be something to consider. But more times than not, you would order the machine with it. I would agree with you there.
it's not such a big deal as long if the rotary is like an S2 or an S3. If that rotary axis is designated with an S2 or S3 or S1, then it's seen as a spindle axis and probably got the capabilities to buy it.
Okay. What kind of parts would work best on a MILL-TURN machine?
I would say, you know, for me personally, my thing is my background is machine alignment prior to getting into the applications and service side of the world. Um, my background is machine alignment, and one thing I can say for certain, the less that human beings touch parts, the more accurate they are. And that what I mean by that is the less I have to take that part from machine to machine to machine, the more accurate that part is going to be. So, especially when you start talking about the type of advanced machines you see that are built from, they're generally, a more advanced machine and a little bit, higher quality build machine. So, generally, if you're trying to have milling and turning on a part, then and accuracy is important, it's definitely a way to go. If you're trying to eliminate processes, the more you can hold that part from the bottom and get to all 5 sides of it, the 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 better off you're going to be from not just an accuracy standpoint, but just efficiency standpoint. Now, if it's primarily a turned part, I would probably go to a turn mill. If it's primarily a milled part with turning features on it, then maybe a mill turn. If it's a short part, short and wide part, mill turn, excellent. Like think like a car rim or a big gear or something like that. That type of situation, mill turn. So it all depends on what you're doing. The weight of the part matters. All of that comes into play. I see a lot of aerospace and marine parts going into mill turns. More and more automotive parts going into mill turns. From a job shop standpoint, the versatility that it gives you to be able to say yes to customers that want you to quote parts, mill turn really opens up quite a few doors for your shop. Any part that has any turning features on it and milling features, either a turn mill or a mill turn is something that you should consider. It might not be right, but it's definitely worth taking a look at.
Great. Here we got another question that came in. Can I run my virtual machine for my existing 840D CNC?
Unfortunately, no. Well, let me take that back. Yeah, it's run my virtual machine is a SINUMERIK ONE simulation. You're not going to be able to simulate your 840. And here's the other piece of the puzzle. The programs you write, especially in ShopMill in SINUMERIK ONE, probably are not going to be compatible with your 840. Now, your 840 programs that you're running on your 840 will be compatible with your SINUMERIK ONE. So, we can't add features to the control and then have them be available in the control that never have those features. So that's kind of the hang up there. Yes, you can use it similar, but if you're running an 840, you're probably going to want to run SINUTRAIN, because with SINUTRAIN, we can build an archive of your machine. With an archive of your machine, you can build a simulation. So really run my virtual machine. It's SINUMERIK ONE. And 840 does have a shelf life. I mean, SINUMERIK ONE is the new control. So eventually there is an end of date for SINUMERIK 840. Not for availability of parts and service and all that, just new product.
Good. All right, looks like we got one more question here. Are there any turning cycles that are not supported in MILL-TURN?
I can't think of any. No, none that I know. Chris,
Yeah, I would have to agree. I don't believe there's any that I can think of off the top of my head either.
I'm going to caveat that with I haven't found any.
Yeah, it's probably a better point, a much better point.
There's bookends on that, right?
Back to what Dan had mentioned. It's not like we're creating a separate control to be a mill turn, right? Or a turn mill. It's really just there's a couple MDs and we set which is the primary technology, which is the secondary technology. So if something was excluded, It was excluded when maybe turning was the primary and milling was the secondary just because of the core functionality of that process. But really, all the functions should always be in there because it's really the same control.
Yeah, the only limitation I can think of is if you're in a turn mill, you won't have these probing functions. Sorry, these probing functions in a turn mill.
Right,
Only
because
in a
they were
turn
inherently designed for a milling machine, is I
turning
think
machine.
why we excluded them. No, those probing cycles are designed for
Oh,
a mill.
yes, inherently
Right.
designed for a milling machine. Yes, they're not designed for a turning machine. So yes, that's the only thing I could think of. But this is a mill turn, so it's got it. Well, yeah,
Right.
yeah,
Exactly.
yeah.
All right. So, oh, we got another one that just popped in here. Do you have any limitations with the measuring cycles?
No, not in a mill turn. No.
Yeah, I mean the full library is available to you certainly in auto. Obviously, you have the additional cycles there in jog that Dan was just mentioning. So no, you should
So
not
you
have
have
any.
all your edge detection, all your corner detection, hole detection, your boss detection, any of your 3D detection. It's all still available to you in auto.
Okay. So I think I got to all the questions. Obviously, it's always challenging jumping between a couple different screens here. But if we missed something, I would certainly suggest reaching out to myself, reaching out to Dan. We'd be happy to talk to you further on the topic. And with that being said, thanks again, Dan, for an awesome job. And thanks everybody for joining us for another one of our webinars here. It is the Memorial Day weekend. So
It might be
Dan,
S1 and
have
S3.
what was that?
It could be S1 and S3. It's not up to us what they name. They can name it just not.
Right, right. So with that being said, everybody have a great holiday weekend, and thanks again for joining us. And we look forward to seeing you again on one of the next ones. So thanks,
Thank you
Dan.
very much.
Thanks, everybody. Have a great day. Bye bye.